Ever wonder about Earth's baby pictures?
Baby pictures.
Yeah, like glimpse into its earliest days.
Ah.
Turns out they might be hidden in plain sight.
Intriguing.
On the moon.
On the moon.
Yeah, we're talking impact basins.
Right, those massive craters?
Exactly. And today, we're doing a deep dive on a fascinating one.
Okay, which one?
Mare Orientale.
Oh, Mare Orientale, a classic.
Like a giant bullseye.
Yeah, with rings spreading out from the impact.
And what's so special about it?
Whoa.
It might hold the key to understanding Earth's own wild past.
Now that's a story I want to hear.
So why is Mare Orientale so valuable to study?
Well, for one, it's relatively young.
Young.
Geologically speaking, of course.
Oh, okay.
Meaning its impact melt is well preserved.
Impact melt, that's the rock liquefied on impact, right?
Exactly. But here's the catch.
Okay.
It's also old enough to have, well,
Have what?
other features on top, like lava flows and smaller craters.
So it's like a multi-layered record.
Precisely. Imagine trying to see a photograph that's been painted over several times.
Oh, I see. So we need to peel back those layers.
Yeah, to get to that original image.
That sounds pretty complicated.
It definitely presents a challenge.
Especially with a site as large and complex as Mare Orientale.
Absolutely. But luckily,
Luckily.
there's a new geological map.
Oh, tell me about this map.
It's helping us do just that, peel back those layers.
Amazing. What's the goal of this map?
The goal is to pinpoint those areas of original impact melt
Okay.
amidst all the
Amidst all the what?
clutter.
Ah, right, all those later features.
Exactly. And how does it work?
Yeah, how does it work?
By focusing on two key features.
I'm listening.
Smooth, cracked areas of the basin floor.
Okay.
They're labeled BFSC,
BFSC, got it.
which likely contain that original impact melt.
So that's one feature.
And then there's the ejecta,
Ejecta.
the debris launched out from younger crater.
Oh, the craters that formed on top of Mare Orientale.
You got it.
Okay, I see. So you're looking at those two features.
Right. Think of it as digging through layers of a cake.
Okay, I like that analogy.
We're searching for that original base layer
Makes sense.
among all the later toppings.
Okay, but wouldn't ejecta from those younger craters potentially contaminate things?
Ah, you're thinking about the dating.
Right. Wouldn't it mess up our dating of the basin itself?
That's a great question.
How can we be sure we're looking at the right stuff?
Well, the researchers have a clever solution.
Okay, I'm all ears.
They theorize
Yep.
that if samples from both the smooth basin floor
Okay.
and the ejecta from younger craters
Uh-huh.
show the same age,
So same age, then what?
it means that ejecta
The ejecta.
actually originated from that initial impact melt.
Wow, so it was just churned up by later impacts.
Exactly.
It's almost like a detective story.
It is.
We're using clues to piece together the timeline.
Precisely. Of course, to confirm this, we need a sample return mission.
Right, to analyze the actual rocks,
But this map gives us a roadmap.
like a starting point.
It tells us where to dig, so to speak.
I love that. So this new map allows us to create a more accurate timeline
Yes.
of lunar bombardment, which, in turn, directly informs our understanding of early Earth.
Right.
Wouldn't Earth have been hit even more?
Oh, absolutely.
Because of its larger size and gravity.
Exactly. And to understand this period of intense bombardment,
Yeah.
we turn to a fascinating technique.
Lay it on me.
It's called crater counting.
Crater counting.
Yeah.
That sounds pretty straightforward.
It is. More craters equal an older surface.
Makes sense.
It's a simple principle.
Right.
Over time, more impacts leave their mark.
So by analyzing the craters on the moon,
We can estimate the ages of different surfaces.
that's so cool.
The current estimate for Mare Orientale's age is 3.8 billion years old.
Wow.
But this new map could help us refine that.
Even more accurate.
What makes this so valuable
What's
is
that?
we can extrapolate that information to Earth.
To Earth's own impact history.
Exactly. A history largely lost to our planet's geology.
So the moon acts like Earth's attic,
I love...
preserving a record of those early bombardments.
It's a remarkable thought.
Mind-boggling to think about the scale of these impacts
It really is.
and the effect they must have had on Earth.
It makes you wonder,
So,
could these impacts have something to do with
with what?
the emergence of life?
Wow, that's a big question,
It is.
and one we'll have to explore further.
Definitely. A question with no easy answers, that's for sure.
But it highlights the influence of these events, right?
Absolutely, on our own planet's history.
It underscores what?
Okay.
It underscores what?
The interconnectedness of our solar system, I guess.
It really does.
It's incredible to think that something like a giant impact could be linked to, the origins of life.
Precisely. We're talking about a period
Yeah.
3.8 billion years ago.
Okay.
It coincides with the first evidence of life on Earth.
So did these impacts,
They what?
did they create conditions for life?
That's the question, isn't it?
Were they destructive and conducive to life at the same time?
It's a fascinating paradox.
Did they, set the stage for life?
It's a possibility, some might even say.
Really? Like a cosmic reset button?
A reset button.
Wiping the slate clean.
I see what you mean.
Allowing life to emerge anew.
That's a pretty evocative image.
Are there,
what?
specific theories about how these impacts might have actually sparked life?
Well, there are some intriguing hypotheses. For instance, the intense heat from the impacts could have created hydrothermal vents.
Hydrothermal vents, what are those?
They're underwater hot springs.
Oh, okay.
Teeming with chemicals and energy.
And these are considered potential cradles for life.
Even today, yes.
Wow.
They might provide the building blocks for early organisms.
So while seemingly destructive, these events could have created environments for life.
It's a possibility. Almost like
Like what?
a phoenix rising from the ashes.
Yeah, a powerful metaphor.
It speaks to the resilience of life.
It does.
Adapting and flourishing in the face of challenges.
It's a reminder of the fragility of life as well.
The delicate balance.
Yes, the balance that allowed it to evolve.
But if these giant impacts were so frequent back then, why haven't we seen anything similar recently?
Good point. The period we're talking about, it's called the Late Heavy Bombardment.
Late Heavy Bombardment, okay.
It was a chaotic time.
Chaotic how?
The leading theory suggests
I'm listening.
that gravitational interactions between the giant planets.
You mean like Jupiter and Saturn?
Exactly. They caused a sort of cosmic billiards game.
Cosmic billiards, whoa.
Flinging asteroids and comets inward.
Towards us.
Earth and the moon became prime targets.
So we're lucky things calmed down.
Lucky indeed.
Life could evolve without constant threats from space.
Exactly. The rate of impacts declined dramatically.
But, the threat hasn't vanished entirely, right?
You're right.
I mean, we've seen smaller impacts even recently.
We have.
And there's always the possibility.
The possibility of what?
Of a larger object crossing Earth's path someday.
It's a sobering thought.
So studying the moon's impact history.
Yes.
It's not just about understanding the past.
It isn't.
It's about the future, too, right?
It is. It's about informing our future.
By deciphering those clues in the craters,
exactly,
we can understand the dynamics of the solar system.
We can.
The frequency of impacts.
Yes.
And develop strategies to protect our planet.
That's the ultimate goal.
Wow. I hadn't thought about it that way.
It's a crucial aspect of planetary science.
You've really shifted my perspective.
How so?
I used to think of the moon as static and unchanging.
I understand.
But now, I see it as dynamic.
It is.
Ever-evolving, holding secrets about our past, present, and future.
That's beautifully put.
It speaks to the power of scientific exploration.
It does.
Every new discovery adds to our understanding.
It's a never-ending journey.
We've been focusing on Mare Orientale and what it means for Earth.
Right.
But this new map opens up new avenues, doesn't it?
It does, for exploring other impact basins on the moon.
Some even older than Mare Orientale.
Absolutely. Imagine the insights we could gain.
It's like unlocking a new chapter.
A new chapter in the history of the solar system.
It'll be exciting to see what future missions reveal.
I agree.
Speaking of future missions.
Yes.
You mentioned a sample return mission earlier.
Right.
If you were designing one
interesting.
to collect samples from Mare Orientale,
okay,
where would you target? What questions would you want to answer?
That's a great question. One that mission planners are considering right now.
So where would you start?
Well, if I were designing such a mission,
Yeah.
I would prioritize two key areas. I'd start with those smooth, cracked regions of the basin floor.
The BFS key areas.
Exactly. Getting samples from there would give us the most pristine examples that original impact melts. We could precisely date Mare Orientale then and compare it to other basins.
Right.
Refine our understanding of that bombardment period.
Makes sense. But what about those younger craters? Wouldn't sampling their ejecta be important too?
You're absolutely right.
Especially if we want to test that theory.
Yeah, about the ejecta origins.
Right, that some of it came from that initial impact.
My second target would be a younger crater then,
Okay.
but one large enough
We'd have what?
to have excavated material from deep within the basin.
Oh, okay. So by analyzing its ejecta.
We could determine if it matches the impact melt from the basin floor.
And confirm that link to the original event.
Precisely.
So comparing samples from those two spots,
Yeah.
we could confirm that even younger features are tied to that ancient impact.
Exactly.
Like a giant puzzle.
It is. And this approach isn't limited to just Mare Orientale.
Oh, so we could apply it to other basins.
Absolutely. By identifying and sampling key features, the original melt, ejecta, even volcanic deposits.
We could build a timeline of lunar bombardment.
A whole impact chronology.
Wow. A record of the early solar system.
Exactly. We've talked a lot about the destructive potential
Of these impacts.
Yeah, but could they have also shaped the moon?
Shaped it how?
Well, could they have contributed to its mountains?
Or even its internal structure.
That's a great question. Giant impacts can have huge effects.
On
Geology and topography.
Just could have.
Melted rock, uplifted mountains.
Wow.
Even fractured the crust.
Leading to tectonic features.
It's possible some prominent features on the moon.
Like what?
The vast highlands, even those lunar swirls.
They could owe their origins to impacts.
At least in part, yes, to the shock waves and seismic activity.
Amazing to think that events from billions of years ago
I know.
could still be influencing the moon's landscape today.
It's a testament to the power of these events.
Every time we delve deeper into lunar exploration, we uncover more questions than answers. It's both exciting and humbling.
It really is a testament to the vastness of the universe.
And the need for continued exploration.
Absolutely. We need to keep pushing those boundaries.
Seeking answers to those fundamental questions.
The ones that drive our curiosity.
Well said. As we wrap up our deep dive today,
Yeah.
is there one key takeaway you'd want listeners to remember?
I think it's important to remember that the moon is not just a silent observer in the sky.
Okay.
It's an active world with a rich and dynamic history.
A history that holds clues.
Clues about our solar system and even the origins of life.
By studying the moon.
We're not just exploring another world.
We're delving into our own past, present, and future.
Beautifully put.
And for listeners who are eager to learn more, we'll include links in the show notes.
Great idea.
In the meantime, step outside tonight. Gaze up at the moon.
Yes.
Consider those ancient scars.
Whispers from a more chaotic time.
Who knows, maybe one of you listening will be inspired to design the next mission.
To unravel the moon's secrets.
And unlock the mysteries of our cosmic origin.
What a fantastic thought.
Until next time.
Yes.
Keep exploring, keep questioning, and keep looking up.